So a few days ago, our Kenmore electric dryer stopped heating up and the clothes were just never getting dry. So let's go ahead and try to troubleshoot the problem here. As you can see, this is a Kenmore 70 series, and if you open the dryer door, you can check your model number right here. Mine is 667-22692. This troubleshooting process should work for most electric dryers. The parts may look a little bit different in other brands, but the basic construction should be pretty similar for all of them. So first thing we need to do is pull the dryer out away from the wall, and we're going to have to remove the back cover. But before we do that, I'm just going to show you the dryer works. You can see it runs, or you can hear it runs. It's just, like I said, it's not heating. So could be a variety of different causes for this, but let's go ahead and get started. Before we do anything, we're gonna, at least I like to turn the breaker off to the dryer. My plug is behind the dryer. It's hard to get to. I really can't pull the dryer all the way out without unplugging it, which means I've got to reach over the back of the dryer. And the plug is hard to remove from the receptacle, and you could potentially get your finger on one of the prongs, which would electrocute you if the power is still on. So I'm going to start by turning the breaker off, and then I'll try to slide the dryer out as far as I can to unplug it. Sit tight and I'll be right back. Alright, I've got the breaker off. Now I can reach back here and unplug the cord from the wall, and then we're going to need to remove the vent connection. In my case, I've got a hose clamp with, I believe, 5/16 nuts on it. So I'm going to need to loosen those, and that will allow me to disconnect the vent ducting from the back of the dryer, and then I can slide the dryer all the way from the wall and get access to this back panel. So let me do that now and reposition myself. Alright, you can see I got the cord unplugged and the dryer ducting removed, and I have slid the dryer away from the wall and repositioned it so that I can work on it. Next, what we're going to need to do is remove the back panel, which is this metal cover here. It's held on by a series of hex head screws. In my case, these are 1/4 inch. We just need to use a 1/4 inch nut driver like this to remove those, and you can see they are positioned around the perimeter of the cover. You can see I've got a couple that are missing, but we're talking about these guys. The quantity may vary if you have a different model dryer, but we need to remove all of those, and that will allow the cover to come off. Now, there's also a separate independent cover here that goes over the wiring connection. So I'm going to start with this screw here. That will allow this cover plate here to come off. Let me take that screw out and I'll show you a view of that, and then we'll move on to removing the rest of these. Okay, you can see that I've removed that first screw, which allows this cover plate to slide out. It's got a little tab here, right there by my finger, that engages that slot right there. So once the screw's loose, you can just slide it out, and we'll set that off to the side. And as I mentioned, you can see the wiring connection behind there. We don't need to mess with that, so we can move on. So I'm just going to finish removing these screws around the perimeter, and that will loosen the cover plate so that we can take it off. Okay, I've gotten all the screws removed. The back cover is now loose. You can see the ducting connection penetrates through the cover, but there's nothing securing this on there, so the cover will just slide right out from around that vent connection. And now you can see we have access to all the internal components. So I'm going to set this cover out of the way, and we'll move along to testing. Okay, with the cover out of the way, now we can start our troubleshooting process. So let's dive right in here. At first glance, this might seem kind of intimidating, but really there's just a few simple components that we're going to have to check here to determine what the issue is. You can see right here a couple of different components. This is a thermal fuse, which I think is sort of like the last line of defense if the dryer overheats and for whatever reason the other safety features don't turn it off. This eventually will, at a certain temperature, will break the circuit and the dryer will just shut off, and it won't run at all, I don't believe, if that's blown. So that is certainly a possibility. Below that we have what I believe is the cycling thermostat, and this is what should, under normal operation, should cycle the heating element on and off to maintain a fairly constant air temperature in the dryer. So we're going to need to check that. Potentially over here, this here is the housing for the heating element. Up inside here, if you feel up inside there, you should feel some coils. And basically the idea is that air gets sucked in through the back cover, and it's drawn in here to this opening on the bottom of the element housing. The element itself gets hot through electrical resistance, and the air is drawn up through here by the dryer fan, and it's forced into the dryer. So the element itself could be our problem, or we could have an issue with, I think this is a thermal cutoff to prevent overheating, and I believe there's another thermal cutoff here at the top of the ducting before the air goes into the dryer drum. So we're going to need to potentially check all of these components, which is actually fairly simple to do. We're going to be checking for electrical continuity. That's just a fancy word that means the ability of electricity to flow through the circuit. So to do that, we're going to use an electrical multimeter like this one. These come in all sorts of different styles. You can get really fancy ones, or you can get pretty basic ones. I think I picked this one up at my local hardware store for, I don't know, maybe $50 or $60. Everything seems to be more expensive these days, so I don't know what these are going for now. It might be closer to 100, but if you're going to do any sort of DIY maintenance around your house, I highly recommend having one of these on hand, because it's really, it'll pay for itself within a few repairs that you do on your own. So anyway, like I said, we're going to test for electrical continuity. To demonstrate that, my meter has sort of a little symbol with, looks like sound waves here. That's an audible setting for a continuity test. So if we turn it on and set it to that particular setting, that's going to give me an audible sound when continuity is detected. So again, continuity is just the free flow of electricity through a circuit. So if I touch the two leads together, you should hear an audible noise. So before we do any testing, we want to just check to make sure the meter is working properly by touching the two leads together. To demonstrate, I've got a little piece of just a little jumper cable here. It's just a piece of wire, and so in theory, if a circuit is closed and the wire is not broken, we should be able to touch each end of this wire and hear an audible sound. Okay, so that's what we're checking for. We're just going to make sure that electricity can flow through each one of these components. So I'm going to start with the thermal fuse here, because it's sort of the easiest to check and to get to. So we just want to check by removing both wires. Just pay attention to which goes to which terminal. There's two terminals here. I've done this before, and you can see my tags here. I've labeled them left and right. So I'm just going to carefully wiggle these off the terminals. Whoops, let's pull the wrong wire loose. There we go. Tuck those out of the way. And now we want to take our test leads, and it doesn't matter which one we touch to which terminal. We just want to touch one to each terminal, and we should get an audible sound. So, okay, so that tells us electricity is flowing freely through this thermal fuse, which means it's working properly. It's not blown. If the fuse were to blow, inside here the electrical continuity would be broken, and so it would prevent electricity from flowing through this component. So we've eliminated this as a possibility. So I'm going to go ahead and reconnect the wiring to it, and then we will move on to checking the next component. I think I'll check the cycling thermostat below it next. So let me reposition and we'll check that. Alright, so to check the cycling thermostat, you'll see it's got 4 terminals, top and bottom, and left and right. We just want to check the top and bottom. So again, similar to the thermal fuse, we need to make sure we pay attention to which wire goes to which terminal. In my case, I've got a solid red wire going to the top terminal, and I've got a red wire with a white stripe going to the bottom. So we want to disconnect the wiring by gently pulling it off, and then we'll take our test leads and touch one to each terminal. Again, it does not matter which one you touch to which terminal. And if you hear the audible sound, then you know the component is working properly. So we've now eliminated that as a possibility in my case. So I'm going to put those 2 wires back where they just came from, and we'll move on to checking the next component. Okay, the next component I'm going to test is this upper thermal cutoff here. It's just got 2 wiring connections. In my case, I've got a red with white stripe going to the top terminal and a solid red wire going to the bottom terminal. So I'm just going to carefully wiggle these off and get them out of the way. And then I'll take my test leads, and just like before, we're going to touch 1 lead to each terminal. Again, it does not matter which you touch to which, we're just checking continuity. Alright, so you can hear that I've got continuity through this component. So we've now eliminated that one as a possibility. So we're kind of whittling down the variables here. We're down to the last couple of components. So let me reconnect this wiring and we'll move on. Okay, next up I'm going to test this lower thermal cutoff. This actually has 3 wires going to it. There's only 2 terminals, so there's sort of a split terminal here that has, in my case, I've got a solid orange and this red with white stripe wire, and then up top I've got a solid red. So I'm going to disconnect each of those 3, paying attention to where they came from. You'll see that in my case, those are actually 2 clipped together, and the terminal from the component itself slides into this fitting right there. Alright, so just like we've done each time before, we're going to take our test leads, touch 1 to each terminal, and just like that, we can tell there's continuity through this component as well. So now we've eliminated that as a possibility, which tells me that we're down to the heating element itself, unless there's something going on with maybe my dryer timer or something up in the top control board. But let's go ahead and test the element. You'll see that, hopefully you can see, there are 2 terminals here that I'm squeezing right now. Those are the terminals that feed power to the element itself. So in my case, I've got a solid red wire on the front terminal, and that red with the white stripe jumper goes down to there. So Let's disconnect those. Come on. Almost. All right, there we go. Let's pull those out of the way. And again, one more time, we're going to test continuity across these terminals. We should hear the audible sound when we test this, but I'm almost suspecting that we're not going to, given that nothing else has tested bad so far. So let's give it a try and see what happens. So I'm making good contact with the test terminals, with the test leads, and I do not hear the audible sound. Let's test the leads again, just by touching them to each other. So I know my meter's still working, but when I test these terminals down here on the element, there is no continuity. So for some reason, electricity is not flowing freely through the element. So we're going to need to go ahead and remove the element from the dryer and take a look at it and see if it's gone bad. So sit tight and I'll be right back. Alright, so to remove the heating element housing, we are going to need to go ahead and remove the rest of these wiring connections. Again, in my case, I had a solid red in the front and a red with a white stripe in the back feeding the element. Your wiring may be different. Just pay close attention, maybe take a photograph of how this is wired before you disconnect anything else. We also need to remove this wire coming from the top terminal on the thermal cutoff, as well as this double wiring connection from the bottom terminal of the thermal cutoff, like that. Now, we've got 1 1/4-inch hex screw there and 1 1/4-inch hex screw there that hold the element housing in place. And once we remove those two, this element housing itself there's a seam right here. The element itself is going to just drop down, and we can pull it out like this and remove it from the dryer. Let's see if I can do this with one hand. There's nowhere good for me to set up my tripod to show you this, so I'll just hold the camera. So we got the first screw out. Got the second screw out. And now we want to just grab the housing here at the bottom and kind of pull it out this way, like that. And then it'll slide down just like so. If we flip it over, that exposes the element coils. And the idea here, obviously, is that electricity flows through. Ooh, the thing is toasty looking. Something's definitely gone bad on this. But the idea is that electricity flows in from one terminal, flows through the coils, and through electrical resistance, it heats up the coils, and then air is blown over the coils and into the dryer. That's what heats up the clothes as they're tumbled. So something has gone bad here, and if I had to bet, I'm going to guess that the coil of wiring is broken somewhere. Let's see if we can, oh, look at that. I don't know if you can see that. Right there. See how the coil wire is disconnected? I don't know how well this is focusing, but right there in front of my index finger, you hopefully can see right where the wire touches this ceramic insulator. It's broken right there. So let's do a little test just for kicks here. I'm going to put one of my test terminals on this terminal, or test leads on that wiring terminal right there. And I'm going to touch the coil on this side of the break. And we've got continuity there. I bet you if I touch it over here, yep, sure enough, there's no continuity beyond the break in the wire right there. So right there, no continuity. Right here, on the other side of the break, we've got continuity. So clearly the element is bad. I mean, when I pulled it off, you could see how toasty it is. So for some reason this overheated, and that's probably what caused the coil to snap. But in any case, we found the problem. So now we need to get a new part and install it and put everything back together. So I will go try to find a part source for this. I'll link that in the video description. And then we can, once I have that in hand, we can go ahead and get this repaired. Okay, my new part has arrived. I ended up ordering this online from Parts Doctor. I'll post a link in the video description, but I think I paid, with tax, I think I paid about $40 for the new element, not including shipping. So not terrible, you know, compared to if you were just to throw in the towel and buy a new dryer instead of repairing your own. Obviously you're going to spend between, I don't know, $500 and $1,000. I'm not sure what a repair, a service call would cost if you call the appliance repair company. Probably a couple $100 minimum. So certainly cheaper going this route. And I'm stubborn. I don't want to buy any new appliances. I redid my kitchen a few years ago and bought all new appliances, and I have been nothing but disappointed with their quality and longevity. I've already had to repair my dishwasher, and now I've got an issue with my refrigerator water filter housing. So I'm going to keep band-aiding this old dryer as long as I can. Parts are relatively inexpensive, and I know how to repair it. So anyway, I was glad to get this new part in. Took a couple of days to get, but we're ready to put everything back together now. Just for illustration purposes, let's go ahead and just test continuity in this new part. Again, I've got my multimeter set to the audible continuity test. I'm just going to touch one lead to each of these terminals. I'm going to use the holes in the wiring terminal to hold the first lead. And I'm going to touch the second lead there, and you can hear the sound. So as you would expect with a brand new part, it's working properly. We've got electrical flow all the way through the coils, so we know that this part's good and we can go ahead and reinstall it. So let's move along. The first thing we need to do is swap over this thermal cutout here. We tested this earlier. We know that it's working properly. So there's just a couple of 1/4-inch hex screws holding it in place here and here by my thumb and index finger. We're going to remove those and swap the entire part over. And you can see where it attaches here and here. So bear with me. Let me get those removed and we will swap this over and then reinstall it in the dryer. Alright, I've got the screws removed from the part at the old element housing, and I'm going to go ahead and lift it out of place, and then we will drop it down into place on the new element housing, like so. Line up the screw holes, and we'll reinstall those 2 screws, and then we can reinstall this entire assembly in the dryer. Alright, you can see I've swapped over the old thermal cutout, and we're ready to reinstall the housing back in the dryer. And if you recall from Disassembly, it sort of tucks up into this air ducting here. So we're going to need to flip it over like this. And I forgot to mention, just try to avoid handling the coils. You don't want to get grease from your hands or lint or anything on there that could cause them to overheat or burn up. So handle them with care. So again, this orients like this going into the dryer, and the electrical connections face towards the left. So we want to tuck this up inside the ducting like so, and just give it a little bit of a push up there, and then we want to make sure our screw holes are lined up here, and see if you can see on this side. It's tough to see, but hopefully you can see it there by my index finger. Again, those are 1/4-inch screws, like everything else that we've taken off pretty much. So I'm going to reinstall those, and then we can make up the wiring connections next. All right, I've gotten the housing resecured with the 2 screws. Now we're ready to reconnect the wiring. If you recall from disassembly, I had a solid red wire going to this upper terminal here. So we'll slip that back into place. Make sure that it's secure. I had this double wire with a single spade terminal here, or spade connector, that was landed on this bottom terminal here, like so. And the red with the white stripe wire that comes off of that connection that we just made, that goes to the rear terminal for the element. So that guy that I'm touching there with my finger. So we'll reconnect that. And make sure it's slipped all the way on. There we go. And lastly, we have the solid red wire that goes to the other element terminal, like that. Everything is made up. Now we'll just check all of our other connections that we had removed earlier to make sure everything is reconnected and not loose. It looks good. Now we're ready to reinstall the rear cover, and we can reconnect the ducting and power it up and see if we get heat. Now, if any of your other components had tested bad in this process, then obviously you would want to replace that specific component. They're all held in with just a series of screws. You can see this guy has a single screw here that could be replaced easily. Single screw holds in the thermal fuse. Single screw holds in the cycling thermostat. And of course, you saw me swap over this lower thermal cutout with those 2 screws. So all of this is easily replaceable. None of the parts are terribly expensive. So again, in my case, obviously my issue was the heating element itself, but any of these other components could have caused the same issue and can easily be replaced. So if you dig into this and find that you have a different problem, you can still hopefully use this video to replace the part in question and get your dryer working again. Anyhow, let's go ahead and reinstall the rear cover, and then we can get the dryer back into place and connect it and test it out to see if we've resolved our issue. Alright, so I've got the cover kind of leaned up against the back of the dryer, and if you recall from disassembly, it's got this opening here where the vent duct connection pokes through, so we just need to lift it up and basically center it on that. And then now we can proceed with reinstalling all the screws around the perimeter. Again, there's a series of 1/4-inch screws. You can see the holes. We just need to line up the hole in the cover with the hole in the housing and reinstall those. So bear with me, I'll get a couple started and we'll move on. Alright, I've gotten all the screws put in except for this guy here. And if you recall from earlier, we've got this cover plate that conceals the wiring connections. It's got this tab here that fits into a slot in the housing right there. So we need to tuck that in like so. And then the very final screw will go through both the cover and the electrical cover plate and the back cover into this hole right there and anchor both of them. So I will reinstall that, and then we can go ahead and spin the dryer around and reconnect the ducting and plug it in. Alright, well, I'm happy to say that I've gotten everything put back together, and I'm testing the dryer right now, as you can hear, and it's working. The heating element is producing heat again, and you don't have to take my word for it. Got a laser thermometer here. Shoot the wall. You can see where it's reading 73 degrees. Let's open up the dryer. And you can see it's reading 103. This is on the low heat setting. So happy to say that this seems to, this project seems to be complete. Again, this is a pretty simple repair. The problem could have been any one of the components inside, but in my case it was the element. However, I've showed you how to test all of them. So if you happen to find one that does not have electrical continuity through it, that will tell you that is your most likely your one and only problem. I would still recommend testing every component so that you are confident that you're replacing everything that's bad. In my case, the question remains, why did the element go bad? I do know that I replaced this element probably 3 or 4 years ago. I don't think the one that I installed was a factory original. I think it was probably an aftermarket part. So it could have just gone bad on its own, maybe due to poor quality. You know, it's possible that the lint trap got clogged up and was causing excessive heat, or possibly my dryer vent outside. I try to keep that clean, but it's possible that I let that slip, or you know, something, maybe one particular load of laundry had a really fluffy blanket that produced a lot of lint, maybe. Hard to say, but I'm going to keep an eye on it and just make sure it continues to work properly. But for the time being, it seems to be repaired, so I'm happy about that. That wraps up this project, but I hope you found it helpful. I will post links to the element that I bought, as well as I'll show you a photo of all of the other components here at the end of the video in case you need to order something else, and I'll provide some links on where you can get them. I'm not affiliated with any of these sites, just happen to be places that I've been able to find parts in the past. So anyway, that wraps up this project. Thanks very much for watching. I hope you found this helpful.